In this video, we will solve a question on the maximum willingness to pay for an actually fair insurance. The question is, an individual owns a mobile phone valued at 40,000 rupees. The current value of the individual is 2 lakh rupees, including the value of the mobile phone. According to reports, there are 20% chances of mobile phone theft, and an actually fair policy is available to ensure the loss of the mobile phone against theft. The individual's von Neumann Morgenstern utility of wealth function is being given as, that is, utility of wealth is equal to under root W, where W denotes the wealth. We have to find out the maximum willingness to pay for such an actually fair insurance policy. Okay, so what we are being given here, and let's write it here. We are being given a utility of wealth is equal to under root W. Okay, now let's denote, and let me write it here. Let W naught denotes the initial value. Okay, and let's denote L as the loss. Okay, then what will be the total value of the individual? Value of the individual will be equal to the initial value. Okay, here we are being told that 20% chances are that mobile phone will get loss, or there will be theft of the mobile phone. That means 80% chances are there will be no loss of the mobile phone. So initial value will be equal to W naught, which is the initial value. Rather, the total value will be initial value with probability of 0.8. okay, with there are 80% chances that there will be no mobile phone theft. That means in case the total value of the individual will be the initial value. Also, there are chances of 20% of theft, and what will be then the value of the individual? That will be equal to the initial value minus the amount of loss, and its probability is 0.2. okay, 0.2, and we can write it again like this. So that means total value of the individual will be equal to W naught is 2,000, rather 2 lakh, and probability of having the initial value is 0.8 in case of no theft, and W naught minus L means 2 lakh minus 40,000, which comes out to be 1,60,000. okay, there are chances of 20% of mobile phone theft, and in this case the total value of the consumer will be equal to the initial value minus the loss of the mobile phone. Now we have to find out the maximum willingness to pay for such an actually fair insurance. Okay, by actually fair insurance, what we mean, actually fair insurance is where the premium is equal to the expected loss. Okay, in case of actually fair insurance, the premium paid is equal to expected loss. And what is the expected loss? Expected loss is simply the probability of loss times the size of loss. And in this case, what will be the actually fair premium? So that will be equal to probability of loss is 0.2 and amount of loss is 40,000, which comes out to be P will be equal to okay, let's denote it by F subscript with the subscript F. So it will be equal to 8,000. okay, this is the actually fair premium, but we are not interested in finding out the actually fair premium. Okay, we simply say that an insurance policy is actually fair if the premium is equal to the expected loss. Okay, since insurance increases the individual's welfare, he would be willing to pay some price in excess of the actually fair premium to defray the loss, or to defray the risk of mobile phone theft. And we need to find out that very actually fair, rather the maximum willing, how much he is willing to pay in excess of the actually fair premium. Okay, for that what will we do? We will equate, and let's write, we will first find out the expected utility, okay, without insurance, okay, uninsured, let us denote it by expected utility without insurance, and we will equate that very thing with the expected utility with insurance, okay, with insured. Okay, so first thing is we will find out the expected utility without insurance. Okay, so what will be the expected utility without insurance? Let us calculate that. Let us denote it by U, then I naught. Okay, I naught denotes the uninsured here. That will be equal to expected utility. That will be equal to the probability of not getting loss. That means that will be equal to 0.8 times the utility of initial value, that is equal to W naught plus 0.2 times utility of W naught minus L. Okay, how do we calculate the expected utility? Simply we multiply the events with their respective probabilities. So the event is, we will have 2 lakh rupees, and we multiply it with the corresponding probability. And also we have, since we are trying to find out the expected utility, so it will be equal to the probability of 0.8 times the utility of this 2 lakh plus 0.2, that is the probability of loss, times the utility of the wealth in case of loss. So which will be equal to 0.8, utility of W means utility of 2 lakh here, okay, plus 0.2, the utility of W naught minus L means the utility of 1,60,000, okay, which is equal to 0.8 utility of 2 lakh means, so U of W is equal to under root W, so we will have under root 2 lakh plus 0.2 under root 1,60,000. Okay, solving this we will get 0.8 under root of 2000. When we calculate it, it comes out to be 447.213 plus 0.2 under root of 1,16,000 comes out to be 400. Okay, when we do the addition here, we will get 437.77. This is the utility that the individual is getting if he does not insure. Now we need to equate, we need to find out the utility without insurance. Okay, so let me rub this out. We don't need this very stuff here. So we also find out the utility function with insurance, and let's define it here. Let us suppose, let P be the premium he is willing to pay for insurance. Okay, then what will be the utility with insurance? Okay, so the utility, expected utility with insurance, and let's denote it by E U I. Okay, so expected utility with insurance will be equal to, first, the probability of not happening the event, that means probability of not loss, which is 0.8, times the utility of initial value, that is W naught, minus he has to pay the premium in case whether the theft happens or not, so it will be equal to P. Remember this here, okay? Plus, then we are also being told that there is 20% chances of loss, so we write probability of loss times the utility of, and in this case what will be the utility? So we will have the utility of the initial value, okay, minus the loss he incurs, plus the premium he pays, plus the loss he is being compensated for. Okay, let me explain it again. So when he is paying a premium of P, what will be his utility with insurance? That will be equal to 0.8, that is the probability that the theft does not occur, times the utility of the value. What will be the value in this case? That will be equal to the initial value he is having minus the premium he has to pay whether the loss occurs or not, okay, plus 0.2 utility of when the loss occurs, probability of loss times, and in this case what will be the value? So value will be equal to W naught, that is initial value, minus this denotes the loss he occurs due to theft, P denotes the premium he has to pay when he takes the premium, and this plus L denotes the compensation for the loss. Okay, so expected utility with insurance will be equal to 0.8 the utility of W naught minus P. Okay, that is 1 is 10, 100,000, 10,000 lakh minus P, plus 0.2, here minus and plus L gets cancelled. Then we have the utility of we have 2 lakh minus P. Okay, since these are the like terms, we can add them up. Okay, 0.8 U plus 0.2 U, it sums up to be U 2000 minus P. Okay, and we can write it utility of this very stuff will be equal to under root, rather 2 lakh minus P. Okay, I am really sorry if if I was not able to explain it perfectly, because there is so much noise, I am getting distracted. Okay, so this denotes the utility without insurance. Now we equate utility without taking insurance with the utility with insurance. Okay, utility with insurance is equal to 1 is 10 is 100,000, 10,000 lakh minus P, and it is equal to the utility without insurance, which is equal to 437.77. okay, so taking this under root here, it will become square. We will have 2 lakh minus P will be equal to 437.77 square, which comes out to be, transposing this P here, so we will get P will be equal to 2 lakh. 2 lakh minus the square of this comes out to be 191,642.537. That means the maximum amount he is willing to pay will be equal to 2 lakh minus this stuff, and it comes out to be 8357. Okay, this is the maximum price, maximum amount he is willing to pay for the actuarially fair insurance. Okay, I hope I make myself clear in this video. Thank you.